If you're looking to manage the deployments of your applications and get metrics from your deployment process, then this episode is for you. Welcome to Is It Observable? Today's episode is part of the Kubernetes series, where we already covered several topics. We had the how to collect logs with various solutions, so there is Loki, FluentD, FluentBits, and many others. We recently covered what is KubeHealthy, what is Linkerd, what is SCADA, and how to autoscale your Kubernetes cluster. Today's episode, we will focus on a CNCF project that allows us to simplify the deployment of our applications in a Kubernetes clusters. And in fact, I'm referring to the Keptn project. And in reality, I'm more talking about the new version of Keptn, the Keptn Lifecycle Toolkit. If you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see what you're going to learn out of this episode. So we'll start with an introduction reminding our current challenges when we are deploying our applications in our Kubernetes clusters. We will then explain what is the Keptn Lifecycle Toolkit. You will see that Keptn Lifecycle Toolkit includes and introduces several CRDs, so we will look at the various CRDs that the Keptn Lifecycle Toolkit will add in our cluster. We will explain how to create a pre-post task or check in our deployment process. We will look at the observability data that Keptn provides out of the box. We'll have a short interview with one of the maintainers of the Keptn Lifecycle Toolkit, and it's going to be Giovanni Liva. And as usual, we will jump into the tutorial. Do you remember how we used to manage our deployments a few years back?
Yes.
No? Well, let me remind you. First, we were handling 1 or 2 releases per year. We were all working in the same huge Git, in fact, SVN repository. And at the end, we were building and deploying our code, so huge, massive code, to ship it in our infrastructure. And on the infrastructure side, we used to run tests to tune up the environment. Not every time, but for most of the project, we used to do that. And we also did some capacity planning to adjust the size of our environments. Now, obviously, things has changed. We are more agile. Every team is in charge of a component or microservices of our system. So at the end, we have all our own repo with our own sets of validation. So when we deploy each component separately, and all those components or microservices becomes our platform, our application. It means that we need to run lots of validations when we are integrating all those components. Then we will have to figure out the right auto-scaling policy that we need to apply in your future production environment. And of course, we have to implement the right observability with the right SLO and SLI if you didn't already apply it. When deploying our applications in Kubernetes, we need obviously to create a deployment file per microservices. This deployment file, you know it, have one or several containers, a health probe that Kubernetes will use to route the traffic to the right pod, a readiness probe to let Kubernetes determine if our pod is actually running, and also the number of replica that we need. We often add to our deployment a Kubernetes service to add the network layer to our microservices. At the end, Kubernetes will automatically check that the required objects used by our workload are already deployed before actually deploying it. That is one of the checks done during the creating state of Kubernetes. In Kubernetes, there is no notion of applications or dependency. Therefore, if we deploy a pod that, for example, requires a connection to a Mongo database, if the Mongo database has not been deployed before, then our application will try to reach out to this missing service or missing pod, and it will generate errors or crash. If that error is repeated several times, we will get this well-known error, crash to black off.
No, God!
That means that if we need to deploy that kind of systems, we need to manage the right deployment sequence to avoid this type of error. To resolve this issue, we can make those type of tests within our CI/CD process, where we deploy each component and run the proper tests to validate the deployment. To do that, we rely on several CI/CD solutions of the market. So there is the traditional Jenkins, the GitHub Actions, GitLab, Azure DevOps, Spinnaker, Argo CD. There is plenty of solutions out there, so you have the choice. Most of the CI/CD solutions allow us to build a sequence of tasks. Each task corresponds to the interaction with one of our tools for deployment or security scan or testing or whatever. We usually try to use an existing integration with our toolset, but it could happen that there are no integration available. So we need, in fact, to build our own integration using either a container or a command line from the solution, or interact with the API layer of the tool to trigger or to retrieve information. As a consequence, after building a reliable pipeline, we usually end up to copy pieces of our pipelines and reuse them in other project pipelines. After several months, if we look around us, we realize that our copy-paste is almost in all the pipelines of the organizations. The big challenge is that when we decide to change tools, then it means that we need to update all those pipelines.
Oh, okay.
That is the reason several years ago, the project Keptn was created. Keptn is an event-driven framework where tools will register to specific events. For example, I'm a testing tool, I will register to a testing event. So every time there's a testing activity, this tool will receive the right event and do the work after receiving this event. If you need to change tool, you simply need to subscribe your new solutions and remove the previous ones to the right Keptn event. Keptn can do all your CI/CD process, but you can also have the options to only use Keptn for specific use cases. The quality gate, it includes a layer that allows you to evaluate the success of your tasks using the SRE methodology, the SLI and SLO. By the way, if you want to learn more about SLI and SLO, check the video related to it. Keptn also provides production use cases to manage our remediations or our kernel releases. Several months ago, Keptn has released an LTS version of Keptn, the version 1.0. In fact, currently the official release is 1.1.0. The Keptn team is trying to make our onboarding easier and faster for cloud-native applications. That is the reason they decided to release a new version of Keptn, the Keptn Lifecycle Toolkit. Keptn Lifecycle Toolkit is an operator designed to help teams managing their deployments in Kubernetes by introducing this notion of application. You will see that Keptn defines one application by attaching all our various workloads to it. With this notion of application, Keptn will help us to add pre-evaluation before deploying any workload or even the entire application. And the great thing also is Keptn provides out-of-the-box observability related to our deployment cycle. The beauty of Keptn that it does not require any specific configurations, or in fact, a couple of them, but it's very limited. The few things that you will have to do is to first define your application. So what are the workload that makes our application? Add specific annotations to those workload. And last, we will need to label the namespace where our application will be deployed. Keptn will only check the application deployed in namespace having the following annotation. So Keptn LifeCycle Toolkit enabled. Then you simply need to add the right annotations to your workload. So there is several types of annotations. So here are the Keptn ones. So the Keptn app for the application name, the Keptn workload, so you can name the workload name, and last you have the Keptn version for the version. Or if you prefer to use the Kubernetes recommended label, you can also annotate your workload with those. So here are the Kubernetes annotations. Keptn will first look at the Keptn annotations labels, and if it doesn't find it, it will look at the Kubernetes labels. As you can see, Keptn also keeps track on the version of your workload. For example, you can define that your application 1.0 is made of the workload A on version 0.2 and the workload B, which is in version 0.4. That is the reason why the version number needs to be annotated to control the version number. If you don't define any version number in your annotations, Keptn will use the version number of your container. In fact, only if you have one single container in your workload. Keptn Lifecycle Toolkit has a great feature that allows us to create pre-deployment checks and post-deployment checks to our workload, or even to the entire applications. To add specific pre or post-deployment tasks to our workload, you will need to add specific annotations to your workload. So here are the annotations. So you have the pre-deployment task, and then you name the tasks or a list of tasks, and the same thing for the post-deployment tasks. So one single task or several tasks. In this example, verified infrastructure, Slack notifications, and performance tests are the name of the new CRDs introduced by Keptn Lifecycle Toolkit, the Keptn task definitions. In the case of pre- and post-deployment tasks for a specific application, you will need to define them in the definition of your Keptn applications. If the pre-deployment check is not successful, in the case of a workload, the workload will be stuck in the pending state. The other great feature is the ability to create pre-deployment evaluations or post-deployment evaluations on our workload and also on the applications. For example, let's say that we have an application that requires 10 different workloads, so 10 microservices. When we deploy those 10 microservices, we know that in total we require about 2 cores from our cluster. So we can imagine to create a pre-deployment evaluation that will retrieve metrics from a metric provider, so Prometheus or any other observability solutions. We can then build the right PromQL in the case of Prometheus to retrieve the current number of cores available in our cluster and add the right objectives. Keptn will check the required number of cores before deploying anything. And if the cores are not there, all the deployments attached to this application will be in pending. You can also use this notion of evaluation in our workload by adding the right annotations. So here are the annotations for the evaluation. So pre-deployment evaluation. So here you can have one or several evaluations, and post-deployment evaluations where it will be the post-deployment evaluations definitions. When deploying Keptn Lifecycle Toolkit in our cluster, we'll have several components. We'll have, of course, the operator that is composed of 2 deployments. So the scheduler in charge of the scheduling of our workload in our cluster. The scheduler at the end will watch the Keptn applications and the Keptn workload. We have the other deployment, the control manager, that will interact with the admission controller and make sure that the Keptn scheduler will be involved in the deployment process of our workload. Both the scheduler and the control manager will produce open telemetry traces from deployment sequence. There will be, of course, several config maps for each component, a service on the control manager to expose the Prometheus metrics out of our deployments. And of course, it will introduce several CRDs. We'll have the Keptn app, the Keptn workload, the Keptn workload instance, the Keptn task definition, the Keptn task, the Keptn evaluation definition, the Keptn evaluation, the Keptn evaluation provider, the Keptn metrics, and the Keptn version. Like mentioned, Keptn will introduce several CRDs, but in reality, we will only configure few of them. We will have the Keptn app, the Keptn task definition, the Keptn evaluation definition, the Keptn evaluation provider, and last, the Keptn metric. The other CRDs, so the Keptn workload, the workload instance, and so on, will be automatically created by the operator. But what you should know is that the Keptn workload is the object that is going to be created from the annotation that we have added in our deployments. It also maps the current active workload instance. So every time we deploy, those workload will have a new workload instance, and it will map that to the Keptn workload object. The Keptn workload instance will keep track on the status of the various checks that we have defined in our workload. Therefore, if you want to check the progress of your deployment to understand what are the status of the various checks, you will have to check that object. The Keptn task is the object that will be created when our validations are running. The Keptn task will create a Kubernetes job to run our check. The Keptn task will keep track of the status of the current jobs. So let's start with the main object, the Keptn application. The Keptn app will map the various workload that makes our application. The CRD will of course take the name of the application. This reference will be used later when we're going to add the annotation to our workload. For example, so here is the Keptn app, the OpenTelemetry demo version 1.2.1, and I have added the list of all the various workload that makes the OpenTelemetry demo with the right version. Then we will add the application name in the annotation of one of our deployment. For example, here we have the Kubernetes part of OpenTelemetry demo, and then we have the name of the workload that we are specifying and the version. In the Keptn application, we can also specify, if you want, pre-deployment tasks and evaluations and post-deployment tasks and evaluation. So here are the information that you will need to add in the CRD. So pre-deployment evaluation, the list of your evaluations that you will be triggered before deploying any workload. Similar thing with the pre-deployment tasks, and then you do the same thing with the post-deployment evaluations and post-deployment tasks. In this example, so there are several checks and evaluations. So app check network, because it's pre, it will be the first tasks that will be triggered when we deploy any of our workload. Then it will run the evaluation, so the app pre-deployment evaluation. If it's successful, then the rest of the deployment will be going through deployment process. And once all those deployments has been done successfully, then we will go on the post-deployment checks from our application. So you will run first the load test tasks, and once the load test task has been ended, we will run the evaluation, so the response type check. The Keptn app has also an optional property, the revision. If you don't define it, the default value would be 1. The advantage of the revision field is to unblock a pending deployment due to a task that is failing related to an issue on our task definition. So you can increment the revision number and reapply it, so it will restart the current tasks that are in error. The Keptn task definitions is the CRD that will help us to define the various tasks that we want to execute as part of the pre or post-deployment checks of our deployments and our applications. Currently, task supports DinoScript, so you can either code your own check in the task definition, like this. So here is an example, where here our task is simply logging some text. Or we can make a reference to a script that we have already built and store into an HTTP endpoint or GitHub. So here is an example. So here you can see that there is a HTTP reference with a URL where Keptn will get that script, and then we will map some parameters to that script. In the future, we should be able to have other runtimes, especially running container image directly. Keptn evaluation definition. The Keptn evaluation definition is a CRD used to define the evaluation task that we want to run as a pre or post evaluation process. So it could be applied in our workload or in application. And the Keptn evaluation definition looks like this. We need to define a source that will link to an existent Keptn evaluation provider, and then the various objectives. So in this example, we have one objectives, and the query is a PromQL because we're relying on Prometheus. Keptn will send to the Keptn evaluation provider, so here Prometheus, the right PromQL to retrieve the metric. To keep track on the results of your evaluation, you should interact with the Keptn evaluation CRD by doing kubectl get Keptn evaluation in your namespace. The Keptn evaluation provider. A Keptn evaluation provider is a CRD that defines a provider providing metrics. This provider will be, as you saw before, to retrieve data in our pre and post evaluation. The definition of a Keptn evaluation provider looks like this. So you put a name to that evaluation and the target URL. And if you need to authenticate to that provider, then you can add a secret name that will hold the login and the various information to log to your metric provider. The Keptn metric. The Keptn metric is designed to help us reuse data across multiple evaluation definitions. So we will first define our metric. So for example, here it is. So in this example, we put a name, the PromQL for the query properties, and how often we want to retrieve that information. So once it's defined, you will be able to build your Keptn evaluation definition relying on this metrics. So here is an example. As you can see, the source referred to Keptn metric, and then instead of putting a name for that metric, we make the reference to the Keptn metric. And here, we don't need obviously the query. Creating a task or a check requires for the moment to build a Dino script. You can clearly code your script directly in your Keptn task definition like we saw before, but you will soon realize that you often have the same type of checks for many of your deployments. Therefore, it makes more sense to build a Dino script that will be stored in GitHub or a custom HTTP endpoint. When the Keptn task is triggered, Keptn creates the Keptn tasks and a Kubernetes job to execute our scripts. To make it reusable, our script will probably have input parameters. There are two types of input parameters, so the plain text parameters, and the other one, the sensitive information stored in a Kubernetes secret. Let's first look at the plain text parameters. All the input parameter will be stored in a JSON object named data. Therefore, you will need to first collect your data object and then access to the various properties of your script. For example, here we first collect the data variable, and then we parse the JSON objects to get, for example, the hosts, the URL, or whatever we want for this specific action. To use this script in our Keptn task definition, you will configure as follows. So here you can have an example. First, we make the reference to the URL holding our scripts, and then you can see that there is a parameter, map, and the various stuff. So the Lifecycle Toolkit pass the values defined inside the map field as a JSON object, so data. So everything under the map will be basically the various properties of the JSON object. For the moment, Keptn doesn't support multi-level maps. If you need to use sensitive parameters like tokens or passwords, you will be able to use Kubernetes secrets. You will need to pass to the functions using a secret parameter field. For example, then in your script, you will need to retrieve the object named secure data, which is a JSON object with all the various properties defined in our secrets. So for example, so here first we get the secure data object, then we parse it, and then we're able to get the various properties inside of the JSON object. Last, Keptn also add a context variables to our script. That context variable will share information about how this task has been triggered. What is the context of the task? So we will have information about the application and the workload. So context is a JSON object. So we'll have an object type that could be either application or workload. Then for application, you will have the application name, the app version. For the workload, you will have the workload name, the workload versions, and the application name where that workload belongs. The Keptn Lifecycle Toolkit has been built to manage deployments of our application, but also provide the right visibility on our deployment process by providing observability data. All the metrics produced by Keptn will be exposed on the Keptn Control Manager on the default port 2222. Here are the various metrics produced by Keptn. So we have application-related metrics. So we have the Keptn App Active that returns the current active applications. The Keptn App Count Total is a counter returning the number of applications. Keptn App Deployment Duration returns the gauge with the entire deployment of your applications. Of course, the application metrics will have also labels on top of that. So we have the Keptn Deployment App Name, the app namespace, and the app version. We have workload-related metrics with the Keptn Deployment Active, so the number of current deployments, the Keptn Deployment Count Total, so the number of deployment counts that Keptn has been managing, the Keptn Deployment Duration, so the gauge metrics with the duration of the workload deployments, and then we have a Keptn Deployment Duration, which is an histogram storing the deployment durations. All the workload metrics will have the following labels. So we'll have the deployment name, the app name, the namespace, the workload version, the workload status. Task-related metrics. So we have the Keptn Task Active, the number of tasks that are currently active. The Keptn Task Count will be a counter with the number of tasks managed by Keptn. The Keptn Task Durations, it will be an histogram with the duration of the task. Those metrics will also have specific labels, so the deployment app name, the deployment task name, the deployment task status, it could be success or failed, the deployment task types, it could be pre-deployment tasks or post-deployment tasks, and then we have the workload name, the workload version. Last, we have also metrics related to evaluation with the Keptn Evaluation Active that will basically show you the active evaluation tasks. Those will have a specific label, so the deployment app name, the app version, the evaluation name, the evaluation types, it could be pre-evaluations or post-evaluations, and so on. Keptn also provides default Grafana dashboards. We have the Keptn Overview, the Keptn Application Overview, and last, the Keptn Workload Overview. Those dashboards could be easily deployed to Grafana using the sidecar dashboard options of the Prometheus operator. In this feature, you will need to create a config map with your dashboards in a JSON file, and this config map needs to have a specific label. So here is the label, Grafana dashboards = 1. The application dashboard shows you lots of metrics, but it also includes a couple of traces generated. So it will require the specific data source, it's Jaeger. So make sure to add also Jaeger in your cluster and adjust the OpenTelemetry collector pipeline to be able to get those metrics. Out of the Prometheus metrics, Keptn is natively generating traces out of our deployment. So the scheduler and the control manager requires to define the right hotel collector URL. In the next coming release, the Keptn Lifecycle Toolkit will have a Keptn config object, allowing us to define our hotel collector URL. At the end, with the traces and metrics produced by the Keptn Lifecycle Toolkit, we are easily able to collect and expose our DORA metrics suggested by Google. It stands for DevOps Research and Assessments. So here is the link to the DORA research websites. In order to get more details related to the Keptn Lifecycle Toolkit, let's call one of the maintainers of the project, Giovanni Liva, Senior Software Engineer and Product Owner at Dynatrace. Hi Giovanni, how are you?
Hey, Henrik, I'm doing great, thanks. What about you?
Very good. I've spent the last few days playing with the Keptn Lifecycle Toolkit. So first, I have discovered it because I was familiar with the first version of Keptn that I've used with various pipelines. So I have tons of questions about the project. Before jumping into those questions, could you introduce yourself to the community?
Yeah, sure. So, hi, I'm Giovanni Liva. I work in Dynatrace for open source projects. I started as a OpenTelemetry maintainer. I'm also the proud owner of the tool for generating the semantic conventions for the specification. And since 2 years, I've moved to Keptn because I wanted to focus more towards cloud native deployments. And now I'm a full-time maintainer for Keptn.
So behind each project, there is usually a story. Could you explain us why you have decided to build this project? Second thing is, why did you name the project Keptn? And for this new version, why did you choose the name Keptn Lifecycle Toolkit?
Why we created Keptn? Because in the past, when we started with this whole project, the main problem the industry had was Jenkins is too hard to maintain. Pipelines were too complex, and there was this new book about Google, the Observability Engineering book, but there were no tool to support people and the industry to guide them through the good practices. How do you should release your software with SLO validation and such things. So we come up with the idea of Keptn, create a tool which is a perfect implementation that supports you to deploy applications. And why Keptn itself? Because deploying software, it's like navigating in a sea, on an ocean. It's very hard, and we want it to be the guide, your captain that goes with you and drives the ship towards the land. And now we saw that the industry moved from having heavily Jenkins pipeline to have a microservice architecture where pipelines are very now narrowed down to the minimum, and the complexity has been moved towards pushing all these microservices into production, make them sure that they can communicate with each other, and make sure that Kubernetes can receive those services and is prepared to serve your application. Therefore, we come up with a new project, sub-project of the Keptn community, which is called Lifecycle Toolkit, that helps and aims to support you to deploy your application in a Kubernetes cluster. The name Toolkit stems from, we are your toolkit to deploy your application. We are not just a set of tools, but we are a set of things, because the idea of Keptn is to be, or the Lifecycle Toolkit, to be very customizable by you, and it's just the orchestrator of your task. So the toolkit for your application deployment.
Can you share any product updates? What do you have in your backlog?
Yes, so we are finalizing the last PRs, and we are cooking the release of 0.6 and should arrive rather soon. The major feature of this release is the possibility to configure your Keptn Lifecycle Toolkit installation with an option CRD, so you don't need to redeploy the Lifecycle Toolkit every time you want to make a change. Also, we are more production ready because we created a Helm chart for that. So you can also handle releases with that. And most importantly, I think the coolest thing that will come soon is a Keptn metric server. Because if you look at the Kubernetes APIs, there is one special or two special endpoints called metric servers. One is custom and the other is external. But there is a big limitation here, that you can register only a single service on these APIs. And if you want to have multiple observability platforms, such as Prometheus, Dynatrace, New Relic, Datadog, you name it, you cannot. You can only select one of these. And the Keptn generic metric server allows you to create a single point that can register to this API, and then behind the scene you can register all your observability platform to provide data of your cluster into the cluster itself via Kubernetes metrics.
So if you introduce this bridge to the metric server, it means that we could also rely on the Keptn metrics to define our HPA or VPA in the future as well.
Exactly. The idea is that the generic metric server is also HPA compatible, so you can use those metrics to scale your workload horizontally. And we are also preparing some example to integrate with other tools such as KDA.
Okay, so when building this tutorial, I really wanted to use existing testing tools. I often use K6 or Trace or Locusts, but there are plenty of tools out there. Currently, the Keptn task definition only supports Dino scripts. Are you planning to add supports for other solutions or provide the ability to trigger a container that have, for example, the K6 or Trace CLI installed?
Yeah, we know about that limitation. We wanted to, since the project is very young, we wanted to provide the user something that they can start with. And be scripted in their way about how the deployment should look like. But for sure, we have in the roadmap the possibility to run any type of container. Also, in the back of our head is possibility to trigger functions such as Lambda, Google function, Azure functions, those type of things also.
One thing that I thought could be cool is to use our evaluations to create production SLO or alerts. I mean, if I define a post-deployment evaluation on my application, I would probably like a feature that transforms this evaluation into an alert in the alert manager of Prometheus, or an LLM detection in Dynatrace, or any other of these solutions.
Yeah, that's exactly what we have planned so far, because the lifecycle part stems exactly from this idea that since we have an SLO definition, we know when an application is healthy or not, and we can continuously monitor that to check that it's always healthy, and as soon as deviates from what we expect, we can trigger something that makes sure that is becoming back to a healthy state. So it's in the roadmap as a thing to be implemented.
When I looked at the trace produced from the deployment sequence, I immediately made the relationship with the current work from the Kubernetes SIG instrumentation, or even with the project called KSpan that produce spans out of our deployment. I thought to myself, it would be so cool to have traces mixing Keptn deployment sequence with Kubernetes tasks. So if something is stuck when we're deploying due to, let's say, a missing config map, or we don't have enough resources in our nodes, it would be very interesting to look at those traces and understand precisely why we are stuck. Have you thought about combining that?
Oh yes, I'm going to KubeCon just because I want to talk with someone from the SIG instrumentation or from the Waveworks for KSpan, just to start to have some collaboration about how we can propagate the trace context in Kubernetes and be able to then connect the different traces together.
So how can the community reach out to the project, and how can they interact with the Keptn team?
So we have an open calendar where you can find our community meetings. We try to have one in the European zone friendly and one in the US friendly time zone. Every 2 weeks, European one, and every 2 weeks, the American one. 1 week apart from each other. So every week you can talk with us. But the best way of getting to know the project is the code. Especially now we are very young in the Lifecycle Toolkit, so we don't have very good documentation. So the first thing that you could do to contribute to the project is just playing with that and then support us with a bit of more documentation.
I guess there's a Slack for Keptn, and there's a specific channel, I guess, in the Keptn Slack or the CNCF Slack, specifically for the Keptn Lifecycle Toolkit.
Yeah, so we have the Slack from just the Keptn, but we're also in the CNCF Slack. In the Keptn Slack, we have a working group for the Lifecycle Toolkit where you can ask questions, or also in any general channel. Just ping us, we are friendly, we don't bite you, so contact us.
Perfect, so I think I covered most of the questions that I had. So thanks for your time, Giovanni. Thanks for answering those questions.
It was a pleasure. Thank you. Goodbye.
See you. Bye. In this tutorial, we are going to use the Keptn Lifecycle Toolkit with the OpenTelemetry demo application. We will first create an application with a specific version number that has only pre- and post-deployment checks on our workload. Then we'll create a second release of our application, adding post-deployment checks on the application by adding some sort of load tests and also pre-evaluation and post-evaluation. It will be the perfect moment to learn how to use the Keptn task definitions, the Keptn evaluation definitions, and we also look at the metrics and traces produced by Keptn. For this tutorial, we will need, as usual, a Kubernetes cluster, the Nginx ingress controller to expose Grafana, the Prometheus operator, the search manager, the OpenTelemetry operator, the Keptn Lifecycle Toolkit. We will deploy the specific version of the OpenTelemetry demo that has been customized by adding the annotations of the Keptn Lifecycle Toolkit. And we also need a Dynatrace tenant because we will send the traces and metrics to Dynatrace.
Like every tutorial that we deliver at is it observable? There is always a GitHub repository related to this episode. Here we're looking at, obviously, the episode related to Keptn Lifecycle Toolkit. A couple of things here in this repository. So first, you need a cluster like mentioned, and we will need Dynatrace. If you don't have Dynatrace, because we will ingest the metrics to Dynatrace and to Prometheus, but we will also look at the Dynatrace. So here, you should start a trial. So it will bring you to the trial page. Put your email address, and you will get a free tenant to run this tutorial. So once you have your Dynatrace tenant, a couple of things we will deploy with the help of a deployment script. But still, you need to keep your tenant URL. So if I take my tenant here, all the first piece of URL until .com would be your tenant URL. So make sure to copy this, save it, and create that variable DT tenant URL. Same thing, we need to ingest some data back to Dynatrace. So you will have to create a token. So to create a token, very simple. You will have to go to access token on the left menu. So once you're there, you create a new generate token. And here we will keep a name, for example, KLT for Keptn Lifecycle Toolkit. And we will search for ingest. And here you will see that you have metrics and traces. And those are the main one that we're going to use for today's tutorial. So once you do that, generate a token, and then make sure to copy that value because we will need it to add it in the variable. Make sure to then take the value and save it into this variable called data ingest token because it will be replacing a couple of files and so on. Then you will run the deployment file here, and I will let you also deploy the Kubernetes, the deployment of the Keptn Lifecycle Toolkit, and then I will show you how to edit it in a few seconds. So, what you get out of this once you have done the scripts plus the deployment of Keptn. So let's have a look at the namespace. So here, obviously, we will have the technical namespace related to this tutorial. So the cert manager required for the OpenTelemetry operator and KLT. We will have the ingress. Ingress will be used to expose Grafana out of our cluster. This is the technical namespace for Keptn once you have deployed it. So you will have it. And you will have the OpenTelemetry operator system. So that's what you expect. So a couple of things. If I look at the default namespace, we can see that if you look at the default namespace, we have a couple of things there. So we have the Prometheus operator that has been deployed with the node exporter, kubestat metrics, Grafana, the alert manager, and inside of that, it also deploys the OpenTelemetry collector as a daemon set. So those three pods corresponds to the daemon sets. In our application, we'll use the OpenTelemetry demo that will also have a specific collector injected as a sidecar. But here, this is what you will get once you deploy it. If we look at the Keptn namespace, as of now, if you have not configured yet the OpenTelemetry collector URL in Keptn, but you will have at least two pod or two workload deployed. So one is the scheduler, like described, and the other one is the control manager. So one important thing, you will have to do it. I already done it, but I will show you. You will have to edit so we can get the deployment. As of now, we need to point out those two components to our collector, the hotel collector daemon set. So in fact, if I do look at the services in the namespace, there are several services running, and the one that we're interesting is one of those two. Those are the Octet collector services that will be able to receive the traces and metrics. So either collector or headless, it's the same, but in our case, we use this one. So which means if we want to configure our Keptn, we will have to edit. So here I have the command and copy this. We will have to edit the deployments of the control manager and the scheduler. So here, if I go down, you can see that I already have done here the URL of the hotel collector URL has been updated. So make sure to do the same thing. So initially, you will see that you don't have that same URL initially. That's why you need to update that. So that's for the control manager. But of course, we have also the scheduler that needs to be also updated. So here it is. And in this scheduler, if you scroll down, you will have here also same thing, the hotel collector URL that needs to be also. So that's for the requirements. So now let's, of course, don't forget to deploy the default Grafana dashboards. I can show you them. They are provided, so I've included them in this repo. So make sure to deploy it, so then Grafana will pick it up and add it to your Grafana instance. Okay, so now let's utilize the hotel demo. So we'll do that in a few seconds. So I've created 2 versions in this repo with a couple of checks. So let me explain first the type of checks we want to apply. If we open the OpenTelemetry demo application, there is an architecture diagram explaining you the entire architecture. So a couple of things, you can see that there are services that are depending to each other. So we will first apply a couple of checks before deploying anything. So first, the feature flag here, it requires to have the Postgre database. So we can imagine to have as a pre-deployment checks for the feature flags that, yes, the database is actually running, that we are able to connect to the database instance. Then if we move to another service, like the accounting service, same thing, there is a Kafka queue with a couple of services relying on it. So we have the fraud, the accounting, and the checkout that are pointing to that Kafka. So we could at least add in the checkout, the accounting, and the fraud that this is actually responding. Same thing, Redis is used by the cart service. So we can also make as a pre-deployment checks on Redis that yes, the Redis database is actually responding. And then for all the service that has some dependencies, for example, the checkout has the dependencies with the product catalog. Same thing with the front end has the dependency of the catalog, currency also. So for all those services that are basically called by others, we will add a check that, for example, the checkout services has a pre-deployment check. We'll control that the email service is up, that the payment service is up, that's the up. So basically, we follow all those different arrows to figure out that those are there. So then we are confident to actually deploy this deployment. So let's have a look before we deploy anything, how to configure this in a Keptn matter. So if we open the application v1 in our repository, we can see that first I'm defining the hotel demo. Now I'm picking up the actual version of the hotel demo, which is 1.2.1. And I have here listed all the services that make this application running, because we have all the dependency described here. So checkout, shipping, email, and so on. Then so I have defined the application. Inside of that, I have defined the modified or added in the deployment file of this application all the various checks. We take here the accounting services, and we can see that it's part of the hotel demo application that we've just showed you a few minutes ago. Here is the name of the workload, so the same name that is referenced in the Keptn app. And then here I have a Kafka check, because remember, it's the accounting service, and the accounting service, which is here, is relying on Kafka. So we will have a pre-check that Kafka is actually running. So that's an example. If we move to cart services, here cart services rely on the Redis check. So you can see here that we have added that. So let's take, for example, a service that has more checks, which is the case for the checkout. Remember, checkout rely on different services. So here I'm checking that the product catalog is running, that Kafka is running, So here you can see that we have plenty of checks to validate that all the required dependency are running, and then it will deploy the checkout. So that's typically how you define the various checks that you want to apply within Keptn. In this specific version 1.2.1 that we're going to apply, there are no evaluation. We will introduce that with the version 2 of the application. Now, let's have a look at a few of those checks. So first, we have I've created the Postgres. So let's look at the Postgres. If I open the Postgres here file, I could have made it like a script that I have stored in GitHub, but I didn't do it. Here it's one-time usage, I would say, but it could be improved by passing a variable that we just explained in the video. So here in this, how does it work? Here I'm using the PostgreSQL client of support on Dino, and then I'm basically applying here the connection string to the Kafka instance. I create the conf and I try to connect, and then I just disconnect. And if I'm not able to connect, I will throw an error. So that's an example of check. Again, it could be improved. So that's the thing. For the other services, for the Kafka, for the Redis, I do the same thing. If we look at the Redis one, same thing here. I could have also transformed it into actual script that with variables, but here I just did it here. So same thing. I import the Redis Connect client. I connect to the instance, and then I make a ping. And if it's successful, then we are good to go. On Kafka, I was not able to successfully apply the Kafka client, but if you do, let me know. I will be very interesting to hear about you. But here in this example, I just use a DNS. So I'm just making a DNS to check that, yes, the service is there, and that there's a pod actually behind this service. For the other services, most of them I have applied this DNS check that is provided by Keptn in the function runtime. There's a couple of examples. There is the DNS, the HTTP, and there is a couple of Slack and others. But here I use this for the DNS and HTTP. For the front end, pre-deployment check. Here, in this particular case, I am sending a HTTP request, a GET request to the home page. So no specific checks, but here at least I'm checking that I'm able to send an HTTP request to the front end. So that will be the main check. So we will first create the namespace. Then we will create the Keptn app. Okay, so now we have created the application. Second thing, we rely on OpenTelemetry sidecar, or this demo. So I'm going to just apply the sidecar as well in this namespace. Then what we're going to do is we're going to label the namespace. So now it's been labeled for Keptn. And then what we're going to do is basically to deploy all the checks, the standard checks that will be used with the version 1 and later on with the version 2. So there is the deployment and everything. So let's take this. So now the checks exists, the application exists, so which means now we are able to deploy. So I could have deployed this app with Jenkins or GitLab or Argo CD or whatever, but here in my case I'm using the command line, and because it's behind Kubernetes, those checks will be automatically triggered through the Keptn. So the only thing that I need to deploy at the end is basically create this application. So now everything has been deployed. So the next thing I'm going to do is check on the pods. A couple of things are happening. So first we can see that we have the various checks that has been running. A couple of them are currently running. There has been one check that has crashed. The other one is currently running. And as you can see, the one that requires, so the proxy requires the check from the front end, so it's still pending. The load generator as well, so those are the two checks. So once this checks has been finished, then at the end, it should be running. So now if we check it again, you can see that all our checks has been executed properly. And that the other workload that makes our hotel demo running is actually there. So if we couple of things, we can see if with the objects introduced by Keptn, so we can look at the Keptn. So now we have a Keptn workload instance for this new deployment. So I can look at those. And you can see that the phase is completed, so everything has been deployed. And we can see that we have all the applications, the app name, the workload, everything is there. We have the information, and we will be able to see in which phase we are. And we have also the Keptn tasks. So normally here you can see that the task, all the tasks that we've been automated triggered is also there, and I can see the status of the check. Once you connect to Grafana, what you're going to get here, it's been with the dashboards of Grafana, you will get the Keptn application, the Keptn Lifecycle Toolkit metrics, and the workload. So if I look at the app, now we can see that our hotel demo is here, and I'm getting some metrics. So I can see the number of deployment active. I can see the successful stuff, the number of failures. So we have few failures. The time and so on. So with the number of the version that are there. So a couple of statistics is here. So you can see that I already have deployed the 1.2.2 yesterday. So you see, that's why you have this. So this is getting out of the box, which is fantastic. The other thing that we did as well is there is the collector. It's producing also traces. So if I go back to your Dynatrace instance and you go to distributed traces on the left menu, and you click on ingested traces, we have the Keptn Lifecycle operator, as you can see, that generates traces. So we can see that we have the app, the post deployments, we have the hotel demo workload pre-deployment check. So if I click on this one, I would be able to see the trace related to the sequence that we had. So we can see that we have the deployments of the hotel demo 1.2.2 and version 1, first revision 1. And we can see that it's going first with the accounting. There is then card services. We have a pre-deployment task. We can see Redis. And we can see the events. The Redis has finished. So it's already sent lots of details on this trace. So you can understand when you deploy an application where you are actually spending time. So that is very useful with the help of the trace produced by Keptn. So first, if we look at the version 2 here, what I have done first, let's have a look at the application version 2. So we will have to deploy the version 2 because we made some changes so the workload has not changed. But here, what I've done, I've added a pre-evaluation check when the application starts. So, and you will see the PromQL that I've done here. I mentioned about checking the resources, and that will be the main purpose of this one. Then at the end, I am doing a post-deployment task where I am interacting. So I've built a small script with the front end of the hotel demo applications. And last, once that is done, I am doing a post-deployment evaluation to check the response times. So let's have a look at those few things. To make this happen, because I'm using the evaluation, I will need to deploy an evaluation provider. So here, this is the evaluation provider that we will have to apply. Then I can create my my evaluations. So the pre-deployment use, of course, Prometheus. And you can see that the PromQL I'm sending is I am counting the number of CPU nodes in this cluster, and I'm removing the one that has been requested in this cluster. If it's above 2, then yes, I'm fine. I can go further. Then we have the post-deployment task. So the post-deployment task here is basically, like I explained, I'm going to interact with the system. So if I had the chance to run K6, I will have run K6 or low cost. But here I'm using just a standard script where I'm doing a fetch on the homepage, then I'm looking at a get on the cart page, and then I'm trying to look at a browser to a product page. Then after this, I am doing a post-deployment evaluation. In this specific demo or tutorial, I have included in the hotel collector a span metrics processors that will provide a metrics called latency buckets that will count the time spent on every span. So I have a span which is global for the HTTP GET, and I have a span which is global for the HTTP POST. So I'm going to get that. I'm going to check that it's under 170 milliseconds and under 150 milliseconds. So that's from the homepage perspective. Then I do the same thing, but for the product catalog, get product. And here I am checking specifically the get product span, and I'm checking that it's under 40 milliseconds. So at the end, because my app is producing trace spans, I'm able to take advantage of that to make some checks. So to do this, we will first need to, of course, upgrade our application. So So now the application is configured. And then we need to apply the various new checks that we have introduced. Okay. And last, of course, we need to apply this our provider, which doesn't exist yet. And then once we have everything, we can definitely apply this the application in our cluster. So let's have a look at the pods running. And now you can see now containers are starting to create. So now if I do the same with the evaluation, you can see that now it's been successful. So if you want to follow that, you simply need to go to see where you are. In fact, you can see Keptn workload. We have the version 1.1, and then we have the version 1. So we have a couple of things that is running. So the version 2 is currently there, and you can see workload deploy. So the front end is currently being deployed. So which means soon, once the few missing workload is deployed, then we should have the tasks related to our application that will be run.
That's it for today's episode related to the Keptn Lifecycle Toolkit. I think the Keptn Lifecycle Toolkit is very promising and add lots of value specifically when we deploy our applications. I think with the notion of adding continuous check that Giovanni talked about in the Keptn app will be very powerful because it's add this notion of readiness or health probe somehow on the application level, and also push alerts to the observability solution. So in the future, it will be even more powerful. But as it is, I think it's really great to add this notion of pre-deployment checks and post-deployment checks in the scheduling of our workload. The Keptn task definition, as you saw today, is related to Dino scripts, and I'm very eager to see the support of custom containers to rely on existing tools like K6, Locusts, and others, so we can even build more powerful checks as a post-deployment checks, for example. So if you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for another episode.